I'll tell you a funny story.
Yeah.
I'll tell you a very one of the toughest things in repair and calibration is when an instrument is dropped. Okay.
When instrument is dropped.
Okay. That means maybe due to wind, for example, it falls off the tripod, it fell down. Once it falls down, the specifications of the equipment like collimation, horizontality, the body, some parts will be damaged. So these are the things that will take time.
Hi guys, Rise Geo Insights will put efforts to value the life of the geospatial industry experts, surveyors and everybody who is in the geospatial industry. So today we are having Mr. Benson who will introduce himself to you. Mr. Benson, welcome to Rise Geo Insights, sir. So this platform is for you people to make visible and bring values to your life. So I would like you to briefly introduce yourself to our viewers.
I come from, my name is Benson, okay. I come from the service industry for survey equipment, which involves toll stations, GPS, auto level, whatever. So my job is to make sure that the equipments are timely and chronologically calibrated for better results on site. So that's my primary job. And including that, if there are repairs or something like that, we carry out that also. I started my career in 2002, I think. Yeah, 2002. And yeah, still running.
So from where you started your career?
I started with a Japanese company called Sokya. They are the manufacturers for survey equipment. So they have all sorts of survey equipment. They only deal with survey equipment. So it's a Japanese company trained by them. So from that's where I started. And then slowly, yeah, it's been 25 years now, I think.
Yeah, perfect. So it means that you have perfect experience in this industry. So what do you think? A single measurement accuracy matters or no?
See, accuracy depends on two things. One is the accuracy of the instrument. Okay, if you need a lesser accuracy, obviously the price will differ. If you need higher accuracies, depending on the type of work you're doing. Okay, giving you an example, for if you want to construct a bridge, for example, a 2-second or a 5-second accuracy toll station will do. Okay, for land survey, for longer distances, for rough survey, a GPS will do, but it'll give you more range. Okay, this is common for all brands. And for example, for aluminum buildings that are made of aluminum and glass, it is compulsory you take a 1-second accuracy equipment because you need more accuracy there. The other ones are not glass or aluminum; they are just concrete and things like that.
So, what is the most critical aspect in calibrating of the optical instruments such as total station and digital theodolite level or any other part of this, any other product of this series?
Okay, let me start with auto level. An auto level is basically an instrument that is used to check the level, right? So you have an instrument which has to be calibrated. There are two aspects. One is the bubble, okay, and the second is the reticle. The reticle is the your crosshair, you call it. So these two things during calibration of an auto level, we make sure these two both are under tolerance. Not under tolerance. When it comes to calibration, we make sure it is 100% in the not tolerance. It is calibrated properly. When you take it on site, there are vibrations, stuff like that. But every auto level has something called as a compensator, which compensates for the difference of the vibrations and gives you the correct reading. Okay, that is for auto level. A theodolite is something that is used to. It'll show you angles, the horizontal, vertical angles. That's basically used to measure angles for example, a dome.
Dome.
So you need angles, right, to build the dome. Building a straight building is easy, but for a dome, you need per, say, or centimeter, you'll have to make sure that it turns at this angle, the vertical and horizontal. So theodolite is basically used for those functions, angle only. A total station is used. Total station is basically a theodolite, okay, because it gives you angles. Plus, it's got something called as an EDM. Electronic distance meter. Okay.
Wow.
So that is basically electronic distance meter is installed in a toll station so that you can get the distance also from your point to a particular point. Now, in the beginnings, we used to have a target which is called as a prism, right? Nowadays, now we don't need a prism. Nowadays, all equipment are reflectorless. They are all laser. Okay, laser. There are three types of lasers. There is one first class, there is second class, and third class. So it's called 1R, 2R, 3R. So toll stations basically use 3R because so that you can get more range in the laser. So if you use a prism, you get longer range. But then if you don't need a prism, you can hit on the wall and get the distance. You can't fix a prism on every point, right? So you can just use the laser option, and then you can take points on.
So mostly people people thinks that surveying is just like a binary or the 0-1 language of the computer. So when it comes to the final stage, everybody will use the features of an application, but nobody will go to the back end of the application. What was the coding or what was the binary language? What do you think that the surveying job or the surveying instrument is the same thing? People will never recognize something like that, or how?
Okay. Now, during the earlier days, let's take toll station for example. Yeah, they used to use something like you must have known older mobile phones. They use Symbian software, right? So in the earlier versions, they used to use something like that. Okay, so you don't have a color display, and then you use it normally. The later versions now, whatever toll stations, whichever brand you take, it is all color display, and then it's touch screen. All functions have come like a mobile phone.
Ah, okay. Perfect.
Okay, so and it is not binary. There are factors that matter in your reading. Now, every measurement you take, like I mentioned in the beginning, is important. For that, there are two factors. One is the angles, and second is your distance. Your angles, if it's calibrated, you point at a site and then you switch it to phase 2, for example. You see that point. There is a calculation for that. If it's under if the calculation is correct, that means your total station is under tolerance. I mean, it is calibrated. Second is the distance. While calibration, we have something called as baselines. Okay, so those distances, it's called baseline because during calibration, we know the distance from we've got something called as a collimator where we place the equipment and then do the calibration check and whatever. So we know the distance to the baseline. If the instrument, when we take a measurement for the distance, if it gives you the correct distance, that means the EDM, which is responsible for giving you the distance, is also calibrated or it is in tolerance. Okay. Now, if it is not, there are options in service modes, okay, which only service people will know, users won't know. In that, we can go and adjust them accordingly, change the constants, it's called.
So do you think that calibration impact the construction and surveying job?
Okay. Now, let's say you have a car.
Yeah, I have a car.
Okay. Now, you don't give it for service. What happens end of the day? Your engine oil, okay, it becomes black.
Definitely.
Okay. Your gearbox oil has to be changed. Okay.
Definitely.
Your tire pressures have to be checked. Your wheel balancing, things like that are there. Similarly, a toll station is an electronic equipment, but it's got mechanical parts also, right? A vertical axis, there is a horizontal axis, there is the EDM, okay, your beam, if it is going in the correct direction. So for that, there are some factors, right? First is the horizontal vertical angles we'll have to check. Second is something called as collimation, which is very important. Collimation basically means that you're sighting at a point, you're looking through the toll station, you're sighting at a point, okay, say a dot or a prism or a reflective sheet for that matter. When I press the laser, I should be sure that the laser is exactly hitting the same point that I'm viewing. That is called collimation. So that has to be adjusted. Second. Third, something called horizontality. Horizontality and verticality. Verticality is something that when I rotate the instrument, okay,
yeah,
the vertical axis, it should turn equally.
Yeah.
Yeah. If it is not like this, if it's bent, the instrument will turn like this. Yeah. So that is verticality. We should make sure there are checks for that, which service people know.
Yeah.
So it has to be vertical. Second is the horizontal axis where the EDM turns. Okay. If it is like this, the EDM will turn like this.
Yeah, definitely.
Yeah. So it has to be straight. So that is horizontality. So all these things have to be checked. And finally, there is something called as an optical plummet.
Yeah.
which is used
To
to
measure the benchmark.
yes,
To put the benchmark.
yeah, not measure as in place the instrument according to the benchmark given by the municipality. or
Yeah.
whatever. That is the
Perfect.
optical permit. So once you fix the instrument on the tripod and then fix using the optical permit, when you fix the instrument on the benchmark, next what you do is start the survey. Next step is you have to adjust your bubble. Now all tool sizes basically have an electronic bubble. That's a component it's called an electronic compensator. It's a component inside the tool station. So you have to level it and make it 0, okay? And then you start your survey.
So now let me ask you what makes your calibration service center over here in UAE, apart from other calibration services. There are so many calibration services, and among them, one of them is your calibration service. What makes difference between you and others?
Okay. Now, I'll put it very short. Okay.
Yeah, definitely.
First of all, experience matters.
Yeah,
Okay.
perfect.
I have a car. I can never drive like a taxi driver
Yeah,
because he knows all the routes. He's very good in changing lanes, everything.
yeah,
Yeah. So
yeah, perfect.
So there is a difference.
Yeah.
So first is experience. Second is the equipment, the master equipment, which I said collimator is of good quality, and then even the collimator needs calibration. It is chronologically calibrated. So in our service center, what we follow is every 2 weeks we make a check. It is not necessary it has to go out all the time, right?
Yeah,
But it is necessary that we conduct the check.
quality you control.
Yes, it's called quality control, and
Yeah.
then we have, we maintain a certain sheet of when it was last calibrated, because if there is audit or something like that, we can show them this is the results of the latest. So we maintain
The current results you will
yes,
tell them.
yes,
Yeah, you mean the current results, you will tell them that this was the result when you brought and this is the result currently.
yes.
Yeah, perfect. And let me know what the process and procedures that you follow with the companies locally, and what the policies and the procedures to international market to make sure that every surveyor is using a calibrated instrument to confirm the accurate measurement.
Now, according to the UAE law, okay, a consultant will go to site and check what is called as a calibration certificate.
Yeah.
It should be valid, okay. And according to the rules here, okay, a certificate is issued basically for 6 months. Okay, it is not necessary that the instrument specifications will go out of tolerance after 6 months. It can maybe run for 1 year, 2 years if you maintain it properly. But it's the rule here that you give it for every 6 months. So here, most of the service centers I know, they issue, even us, we issue the certificate for 6 months. Internationally, there are some service centers who issue certificates for 1 year.
Yeah.
It depends on the surveyor or the company.
I would like to know, or maybe my viewers would like to know, what is the process over here in UAE, and they will tell that what the process in their country, because our podcast is reaching more views and more people across the borders. Yeah.
Yeah. So it depends on the company, okay, and secondly on the customer. Now, if the customer says I don't have transportation, we are ready to pick up and deliver.
Yeah, it's perfect.
Some customers say no, I'll bring it to you, okay, because I need it urgently. So we put those instruments, those customers on priority basis. We have we have a schedule, right? So accordingly, we have already committed to some customers. Okay, you will get your instrument in 2 days or whatever. But if it's a priority instrument, obviously it will be given priority, and then he needs delivery. We can deliver, pick up, whatever. But some customers prefer to bring the equipment and give it to us because his work is urgent, so he will wait, or if it's simple calibration, that is, there is no other problem. So we do servicing, everything, degreasing, greasing, everything. We'll open up and everything, do everything so that the smooth rotations will be there, and then we calibrate and give the instrument. So customers who come as walk-in, obviously they need it urgently. So there is walk-in as well as we pick up and deliver.
Perfect. So, could you tell me something which was very rare in your job career or your calibration service career? That was, and you cannot forget that moment.
I'll tell you a funny story.
Yeah.
I'll tell you a very one of the toughest things in repair and calibration is when an instrument is dropped. Okay,
When instrument is dropped.
dropped.
Ah.
Okay. That means maybe the due to wind, for example, it falls off the tripod. It fell down. Once it falls down, the specifications of the equipment like collimation, horizontality, the body, some parts will be damaged. So these are the things that will take time. So that is the most major thing that.
So, what about your relation with the surveyors? Do you take the concerns of the surveyors or no? Because they are using, at the end of the day, they are using the instrument.
Correct. Okay. Now, who manages? Okay, we'll send it to my organization, for example, for calibration. Okay, I know. Yeah, Benson. Yeah. Okay, so send it. So the driver brings the equipment, but when I call whoever's contact is there, he's in purchase. What would he know? So I take the survey's number and I ask him, is there any specific thing? Because when I check the instrument, there's no problem. So I'll ask him, is there anything specifically that you need to mention that is anything is out of tolerance or whatever? He says, no, it's only calibration. Some surveyors, they don't mention. They mention, but the purchaser won't mention. So those I can find out during our checks. We've got something called an estimation, right? So during estimation, I know there is this factor that has gone out of tolerance or this has to be adjusted. But still, we call the surveyor and ask him, I know, so what he'll face on site. So I'll ask him, are you facing this issue on site? He said, yes, but I don't know why. Obviously, he won't know because I'm the service guy, right? So I'll tell him, okay, fine, we'll fix it for you. So that's how we understand.
Mr. Ben, let me tell you a final advice for surveyors or for the field of industry. So, in all over the world, people are thinking that survey equipment or surveyors are not compulsory. So, as a final advice, that how much important they are in this journey of life, or what's the position of the surveyors or the survey instruments? You can tell the survey instruments because at the end of the day, the survey instruments make sure that an accurate measurement.
Okay. Surveyors are important because they do the survey, right? So surveys are important. Now the critical part here is if the instrument is not calibrated or if it's out of tolerance. See, so obviously when he takes a reading or he's trying to build a small villa, for example, his instrument is not calibrated. So it's not under tolerance. It's giving you a wrong reading. So this is cumulative. What happens is it starts, you get first point, you get an error. As you go further, what happens? Instead of this line, it'll go like that. With the distance you go, you're measuring, right?
Yeah.
As you proceed further in your...
for the positioning.
Positioning, yes.
Yeah.
So when you go further, your error increases.
For example, if you have 5 second error over here, it will increase in the next step to 10 seconds.
Yes, it is incremental.
Yeah.
So basically it will increase. So if it's calibrated, obviously you're getting a straight line. If it is not, here you'll get little, then it increases. So it's always important that the instrument is calibrated so that its specifications or technical specifications are within the tolerance limits for it to give you the right reading.
Thank you so much to be part of our podcast, and we will be more. It was my pleasure to have you on my podcast platform. So we will be more happy to make visible you to the surveyors in this all industry, same like other parts of the industry, geospatial products and geospatial solutions.
First of all, Mr. Nasser, thank you for having me. It is with great pleasure, I tell you. It is very interesting to talk to a person who's technically sound. If a person is not technically sound and
it's my pleasure.
Yeah.
It's
Thank
my
you
pleasure.
Very much. Thank
You're honorable. Thank you so much, Mr. Benson, and thank you so much to have us until this period. So follow us on the YouTube, Instagram, and Tech Talk to be our followers. If you people would like to be the part of this journey, you can be on this chair with us and you can share all whatever you have, the problems, challenges, and the solutions for the geospatial industry. Thank you so much.